Okay, so now we look at 1.7 linear inequalities and absolute value inequalities. The first thing we're going to review is interval notation. So with some sets of real numbers, they can be expressed using interval notation. Suppose that A and B are two real numbers such that A is less than B. So I went ahead and took a screenshot of your book, and that's where this table came from. Okay. It's also on our Google slide review activity. Remember with your parentheses, that's anytime you have a less than or an infinity or negative infinity. Okay. And then our brackets are always going to occur when we have that equal to. Okay. So parentheses, we're looking at less than or greater than, and brackets are less than or equal to or greater than or equal to. Okay. So we're going to be looking at going back and forth between interval notation and set builder notation. Set builder notation is just an inequality. Okay? It's just rewriting it so you actually see the inequality symbols. So if we look at A, we have -1 to 4. So sometimes this is actually easier to graph first. So I'm going to go ahead and graph it. All right. So -1, and we're going to graph that with a parenthesis. And then at 4, a bracket. And then fill it in. Okay. So we're going to say we have -1 and we have 4 with x's in between those. Okay, and now you're going to bring in our rules. So we know whenever we have a bracket, we're going to have an equal sign. And since -1 is in between these two numbers, we're going to put a less than sign on both. To finish out your set builder notation, we're going to put a vertical bar, which means such that, and an X in front of it. Finish it off with our set braces. So now we have X such that -1 is less than X, which is less than or equal to 4. Any number that holds true on that fits within inside that interval notation. So now if we look at B, if we go ahead and graph this, we have from -4 to infinity. Okay. At -4, we're going to have a parenthesis to match our interval notation. And we're going to continue to go to our arrow to represent our positive infinity. And I'm going to make that arrow just a little bit darker to show that it's going to keep going. Okay. So for our set builder notation here, we don't need to include two numbers. Okay, we have the set of all values of x such that here, follow your arrow sign. So your arrow looks like greater than. So x is greater than our number, so -4. And we're using greater than because it's a parenthesis instead of a bracket. All right, so now if we apply that, so solving linear inequalities in one variable. So the thing to make sure we remember is that if we multiply or divide by a negative, we need to flip the direction of the inequality sign. Okay, that's the most common mistake. So looking at A, we have -2x minus 4 is greater than x plus 5. I like to personally always leave my x's on the left, so that way it's already set up. So I'm going to subtract the x that's on the right and move it to the other side. So we have -3x minus 4 is greater than 5. We're going to add 4 to both sides. So -3x is greater than 9. Then divide both sides by -3. Since we're dividing by a negative, we're going to flip our inequality sign. So x is less than -3. All right. So it asked us to solve, which we did. It asked us to graph on a number line. And since we're less than, we're going to have a parenthesis. And we're going to go to the left. Okay, so remember on your number line, if you need to, add in the negative infinity, positive infinity. So our interval notation is going to match this. So we have negative infinity, which always uses a parenthesis, going to -3 with a parenthesis. And then our set builder notation is really easy because we already did it when we solved. We're going to have our set brace, x, such that x is less than -3. And that's your solution. Okay, so looking at B, we have the quantity of x plus 3 divided by 4, which is greater than or equal to the quantity of x minus 2 divided by 3 plus 1/4. So I know on our last video I talked about finding the least common multiple. Another way you could think about it is finding your least common denominator. So if we look at the least common denominator between 4 and 3, that would be 12. Okay, so if I put a 12 above each of these, and we divide, 12 divided by 4 is 3. So 3 times the quantity x plus 3 is greater than or equal to 12 divided by 3 is 4. So 4 times the quantity x minus 2. And 12 divided by 4 is 3, which gives us plus 3 times 1. If we distribute, we get 3x plus 9 is greater than or equal to 4x minus 8 plus 3. So now we're going to combine like terms. We have 3x plus 9 is greater than or equal to 4x minus 5. Again, I prefer to always move my variables to the left with inequalities. So I'm going to subtract the 4x. So we have negative x plus 9 is greater than or equal to -5. Subtract 9 on both sides. I'm going to move over a little bit since I'm running out of room. We get negative x is greater than or equal to -14. Divide by -1 on both sides, which means we're going to need to flip our inequality. And we get x is less than or equal to 14. And now we can, I'm actually going to just take our answer here and bring that down to fill in our set builder notation. And then if we graph it, here we're going to have a bracket because we have that equal to sign. And we're still going to be facing the left because it's less than again. And then if you need to, add in our negative infinity, positive infinity to show our interval notation is going to go from negative infinity to 14 with a bracket. All right, looking at C. 2 times the quantity x plus 4 is greater than 2x plus 3. So if we distribute, we get 2x plus 8 is greater than 2x plus 3. Subtract 2x from both sides. And we get 8 is greater than 3. Okay, our variables canceled, but we have a true statement. So whenever we have a true statement, that means we're looking at all real numbers. So interval notation would be negative infinity to positive infinity. Okay. And then our graph is just going to be a solid darkened line. All right, and looking at D, we have x plus 7 is less than or equal to x minus 2. We subtract x from both sides. We get 7 is less than or equal to negative 2. Well, that's a false statement. So we have no solution. A lot of times we represent that with a circle with a line. And if you were asked to graph it, you would just have a blank line. Okay.